So this is it, the big day. This is what we've been building up to all week with all these other sections. And this is something that we're going to use pretty much the entire rest of the course and use throughout calculus. Super important, the unit circle. Should have done a lot of this in Algebra 2. So unit circle is just a circle, but the unit part, unit means 1 in math. Like the ones digit can be called the units digit. And so what is 1 for the circle is the radius. The unit circle is just a circle with radius 1. So yesterday we looked at taking a look at an angle and its terminal side and a point that it passes through. And based on the x, the y, and the radius, the distance from the origin, we can find our trig values. We're going to use those same relationships. It's just we're going to make that radius, that distance from the origin, always be 1. And so that simplifies our relationship. Yesterday's sign was y over r, but y over 1 is just y. And then cosine was x over r, but x over 1, that's just x. So if we use the unit circle, we've got nice, real simple relationships for the sine and the cosine. Sine is just the y coordinate. Cosine is just the x coordinate. Tangent does stay the same as yesterday. Tangent is y over x. And so we've got this whole big unit circle here that we're going to fill in. You might remember doing this from Algebra 2. And so we'll start with the quadrantal angles. So straight up is pi over 2. Well, because this radius, this distance is 1, well, we didn't go anywhere sideways. So we know that the x is 0. We went up 1. So the y is 1. Then we can go over to pi. Now we're going a distance of 1 to the left. And so now our x is going to be related to that 1. But the thing is, since we went to the left, that's going to be -1. And then the y is going to be 0. And then straight down, we've got 3 pi over 2. So we can go anywhere sideways, so that's 0. Now we went down 1, so that's -1. And then back to a full circle. You can either count this as having gone nowhere, as the angle is 0, or you can count that as a full circle, 2 pi. And then the coordinates are 1, 0. And so once we know these coordinates, again, the whole point of this is now we can find trigonometric values super easily. If I ask you sine of pi over 2, that's just this y coordinate right here. Sine of pi over 2 is just going to be 1, piece of cake. Okay? So then we also want to use our angles from our special right triangle. So we're going to be mainly in radians in pre-cal and all in AP Calculus, all radians. But just to remind you, it was 30, 45, and 60. But then with radians, 30 was pi over 6. So 3 actually goes with 6. Again, 180 divided by 6 is 30 degrees. And then 60 degrees was pi over 3. 180 divided by 3, 18 divided by 3 is 6. And then we've got pi over 4 for 45 degrees. And so then what we're going to do is we're going to use those special right triangles we have. We're going to draw in the right triangle there. Now the thing is, we do have to adapt the special right triangles just a little bit. So in geometry, you learned it with a hypotenuse of 2. But now we need the hypotenuse to be 1. Well, where do we get these from? Well, these are similar triangles, so the sides are in proportion. And so we can just scale them by a factor of 2. We can just divide all those sides by 2. To go from 2 to 1, you have to divide by 2. So the other sides get divided by 2 as well. So we get this 1/2 in this √3 over 2. And so we're just going to take this triangle right here, a little cutout version of it, and we're going to put it on the unit circle right here. So we've got this hypotenuse, this radius of 1 right here. And so then this side is 1/2, and this is √3 over 2. So we've got the 1/2 here and the √3 over 2 there. Well, this opposite side is a vertical distance, so that's your y coordinate. So 1/2 goes right here. And then this side is a horizontal distance, so that's x. So √3 over 2 right there. Now, what we do is now we look for where else we can make use of that same triangle all around the circle. So we can also put that same triangle over here. If we use a reference angle of pi over 6 on the left side there. So we fit our special right triangle into the unit circle there. And again, we're going to have the y coordinate is 1/2. And then this horizontal distance is root 3 over 2 again. But the difference is now for this x coordinate, now we're going to the left. So now we're going to have negative root 3 over 2 for that x coordinate. Then the question is, well, what angle is that we just found the coordinates for? Well, we know the reference angle is pi over 6. And so we're wondering, what is this angle right here? Well, this angle is just a little bit less than half a circle, a little bit less than pi. So if we take pi and subtract out that pi over 6, we take pi and go backwards pi over 6, we'll find the angle we're looking for. Well, pi is 6 pi over 6. So 6 pi over 6 minus pi over 6. This angle we just found is 5 pi over 6. You can also count around your unit circle and look for pi over 6 angles that don't simplify or reduce. So we have 1 pi over 6 here, 2 pi over 6. Well, 2 over 6 reduces to 1/3. Then we'd have 3 pi over 6. 3 over 6 reduces to 1/2. 4 pi over 6. 4/6 reduces. So 5/6 is the next one that does not reduce or simplify at all. So 5 pi over 6 is our next pi over 6 angle. So we look for the next place we can use the same triangle, and that would be down here. We have a pi over 6 reference angle right there. So we'll try to fit this triangle in right there. We're still going to have this side right here being 1/2, and this side right here being root 3 over 2. The difference is now they're both going to be negative. We went left and down. So we're going to have negative root 3 over 2 and negative 1/2. And in terms of what angle that is, well, you can either keep counting around. We have 5 pi over 6 here. 6 pi over 6 is the same thing as 1 pi. And so this is going to be 7 pi over 6. Or you could say that we take pi and then add that pi over 6 reference angle. If you do pi plus pi over 6, again, 6 pi over 6 for common denominators. 6 pi over 6 plus 1 more pi over 6, we're at 7 pi over 6. And so now there's just one more spot where we can use that same triangle, put that triangle in down here, use your pi over 6 reference angle right there, draw in that reference triangle. We've got 1/2 here. Again, this hypotenuse always had to be 1 because we're on the unit circle. And then the root 3 over 2 is still right there. And so for the x coordinate, we went to the right. So that's a positive root 3 over 2. But for the y coordinate, we went down. So that's a negative 1/2. All right. So in terms of what that angle is, if you keep counting, so you have 7 pi over 6, 8 over 6 reduces, 9 over 6 reduces, 10 over 6 reduces, and so now we're at 11 pi over 6. Or you could take 2 pi and go backwards, pi over 6. And so 12 pi over 6, same thing as 2 pi over 6, 12 minus 1 gives us that 11 pi over 6. And so then we can do the same thing for our 45 degrees, our pi over 4, and our 60 degrees, our pi over 3. For 45 degrees, we just have to divide this triangle by root 2. That's how we get to the 1 right there. And so then these other sides have to be divided by root 2 as well. And so this is the rationalized version right there. If you prefer to memorize it as unrationalized, that's perfectly fine. If you'd rather remember 1 over root 2 instead of root 2 over 2, that's not a problem. And so we would just do the exact same thing here. You could either say 1 over root 2, 1 over root 2, or root 2 over 2, comma root 2 over 2, whichever you prefer. And then you would take those coordinates, find the spots all around the circle, and fill those in. And then similarly for pi over 3. If you would like to fill out the whole rest of the unit circle yourself, you can maybe pause this video now and do that for a minute. But we do have the complete unit circle for you, the next page in the notes here. And so here's the whole unit circle. Now the idea actually is not to memorize this whole unit circle. I mean, if you want to do it that way, you could. But actually all we're really going to need is just this first quadrant right here. We do really need to memorize these. These are really, really important to know. And then if we know those, the other quadrants, it's all basically the same, just possibly some negatives. And we can use ASTC to help us figure that out. So we've got some examples here. So these are the kind of problems that you're going to be seeing a whole lot. We're going to give you quizzes on these regularly. Usually your first day of AP Calculus, right after summer break, right off the bat, they give you a quiz on these kind of things. You want to get really, really comfortable with these. Okay? And so there's different ways to look at them, but the way that I do them is first I sketch the angle. That's why I said sketching rating angles would be super important. And so a straight mark there. So 2 pi over 3, if you sketch that. Well, remember our reference points. We had pi over 2, half a pi. We had 1 pi there. This is 3 pi over 2, so 1.5 pi, and 2 pi right there. So 2/3 pi, 2/3 is between a half and 1. And so we're going to have our angle right there in the second quadrant. And so that's where we're going to be using ASTC all the time. So if we're in the second quadrant, we know that sine is positive. So I know that my answer is going to be positive. Well, then I just need to have that memorization piece. So the great thing is that as long as the angle is simplified, if you've got any number of pi over 3, the reference angle is pi over 3. And so other than the positive or negative, these trig values are all going to be the same as what happens for pi over 3. That's why we only needed that first quadrant part memorized. I can take a look at this and just say, all right, I know pi over 3, I know this point here. So the y-coordinate for pi over 3 is root 3 over 2. And so then the y-coordinate here is also going to be root 3 over 2. Again, sine is y. And so my answer is just root 3 over 2. So then for cotangent 5 pi over 3, again, the first thing is make sure you know how to sketch the angle well. So that's 1 2/3 pi. So 1 2/3 is more than 1.5, but less than 2. So we're in the fourth quadrant. In the fourth quadrant, only cosine is positive. Cotangent goes with tangent. I know this is going to be negative, so I'll write that negative right away so that I don't forget at the end. My answer has to be negative there. And then usually for me when I'm doing these reciprocal functions, I do kind of the regular one first. So I would take a look at tangent. I know tangent is y over x. Again, I just need to have this memorized. I need to have that y and that x for pi over 3 memorized. And so the y was root 3 over 2, and the x was 1/2. And then what's going to happen is those over 2's are just going to cancel out. So tangent would be root 3 over 1. And so if you're not sure about that, you can always write that out. So we have root 3 over 2 divided by 1/2. So that's root 3 over 2 times 2 over 1. So that's why those 2's cancel out right there. All right. And so if tangent is root 3 over 1, then cotangent is going to be 1 over root 3. And I've got that negative there already. And that's perfectly fine. Of course, if you want to rationalize it, you can, but you don't have to. And of course, tangent would have been negative. I usually don't worry about that too much. I usually just worry about my final answer. Right. So then right here, let's start by sketching the angle. It's negative, so we have to rotate backwards. We rotate backwards more than half a pi, but less than 1 pi. So we're in the third quadrant. And in the third quadrant, ASTC, I know that only tangent's positive. So I know my answer has to be negative. And so then I just have to have the memorization piece. I have to look at what happens for pi over 4. Again, as long as the angle is simplified, I just look at that denominator to know what the reference angle is, to know what coordinates I need to be looking at. And so you could either have that memorized as 1 over root 2, or you could have that as root 2 over 2. Either way. And then for this one, so this one's a little bit larger angle. And so you can definitely look at these as those mixed numbers. So we've got 3 and 1/6 pi. Remember, really don't get confused on this. This can trip some people up. A full circle is 2 pi. So you don't have 3 full circles here. You only have 1 full circle. So take out the full circle, take out the 2 pi, and you've got an extra 1 1/6 pi. There's the 2 pi is what you're taking out. Don't ignore all of the whole number. Take out a 2 pi and see what's left. So then when I sketch this, I go 1 pi, that's half a circle. 1 pi is only half a circle. And an extra 1/6. 1/6 is less than a half. So I'm in quadrant 3. So in quadrant 3, I know tangent's positive. So my answer is going to be positive here. I don't have to worry about that. And then I just have to think about what are those coordinates for pi over 6 that I have memorized. Tangent is y over x. And so I've got 1/2 over root 3 over 2 is the x coordinate, y over x there. Again, those over 2's will cancel out. And so I'm going to be left with 1 over root 3, which I already knew is going to be positive. Or if you would like to rationalize it again, that is fine, but not required. Okay. And so one last one here. Here's where you have to be careful. This is where we can trick you. All right. So 18 pi over 4. You're not going to be thinking pi over 4 here. You're not going to be looking at that 1 over root 2 or root 2 over 2 coordinates that you have. This one's a little bit different because this one can simplify. Again, that trick only works if the angles are simplified fully. This one you have to reduce, simplify to 9 pi over 2. So that's not the over 3 over 4 over 6 we have memorized. That's going to be one of those quadrantial angles. So let's look at this as a mixed number, 4.5 pi. So that has 2 full circles in it. Now what I'm going to be looking at just a half a pi. It's 2 pi plus 2 pi plus half a pi. When I sketch this, I really don't care about all the full circles. That was the idea of the coterminal angle. It doesn't matter if it spins around a whole bunch. It only matters where it lands. And so pi over 2 is straight up. And so I know those coordinates are going to be 0, 1, because the radius was 1. So I didn't go anywhere sideways. That's 0. I went straight up. That's 1. And so then again, usually I do tangent first. Anytime I want cotangent, cosecant, or secant, I do the simpler function first and then find the reciprocal. So tangent, I know, is y over x. So if I wanted tangent, I would have to say undefined. But I don't want tangent, I want cotangent. So I'm not going to worry about the undefined part. I'm just going to go ahead and find this reciprocal. That's going to become 0 over 1, which equals 0. Again, 0 in the numerator equals 0. 0 in the denominator is undefined.